Hey, it's Dr. J. I'm back for another section, 3.2, adding integers. So last time we were talking about the integers and the number line and things like that. Today we're going to learn the basics of addition. So what was I talking about in the last? What did I start talking about in the last example? To introduce the idea of negative numbers would be like a bank account, right? I'm going to spare you the long drawn-out introduction about integers. You can see all of the introduction in part 1, 3.1. I'm just going to get right into it. So suppose your bank account is overdrawn by $321. That's supposed to be a dollar sign. I don't know. $29. If you make $185 deposit, how much money do you have now? What is your current bank balance? And when I say now, I'm assuming after you've made the deposit. Okay. Now remember, you can think of integers as lying on a vertical line. You have your 0 and you have your positive being above 0, and you have your negatives being below 0. Yeah, that's one way to do it. But typically, we like to draw the number line this way, horizontally, so our positives and our negatives are left and right instead of up and down. It really means the same thing. It's just a matter of how you want to think about it. Okay. So suppose I was overdrawn by $321. So that means I'm way over here, negative $321. I'm overdrawn. Yeah. It's often referred to as in the red. Somebody says you're in the red, you're overdrawn. I don't know about you, but when I log into my bank app or something, or my website for the bank, if I'm overdrawn, it'll show me the number in red. Yeah. And then if you're in the positive, that's called in the black. Yeah, that's a positive balance. That's money that you can actually spend. Yeah. Although, you can actually spend negative dollars. Yeah, you just end up getting more into the negatives, and we'll get into that in a minute. Okay, so we're going to make a deposit. Yeah, so we're adding. So adding a positive number means to move to the right. So we are going to move to the right 185 units. 185 units to the right of 321. Now you could just count if you really wanted to, right? It would go 320, 319, Counting takes a long time. You could do it though. 321, you go 320, 319, 318, blah, 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 etc. But it's going to be quite cumbersome, right? So it'd be nice if we had a rule on how to add these numbers efficiently. And so the way we're going to do it is we're going to subtract 185 from 321, and then because we are still in the negatives, we're going to say, well, when I've subtracted 185 from 321, this is where I'm going to end up. I don't know where that is yet. Let's put a question mark here. But I know that that's still going to be negative. Yeah, because 185, its absolute value is less than 321. So I'm going to go ahead and subtract. So I'm going to borrow here. 11 minus 5 is 6. I'm going to borrow again. Oh, it's an 11 again. 11 minus 8 is 3. And then 136. So my final answer is negative 136. Okay. So your balance now is negative $136. Don't really worry about the dollar sign. The dollar sign is usually off to the side. I don't want you double typing it because you do have a dollar sign on your keyboard. Just the dollar sign represents what we're actually talking about. So that's your answer. I like to do all the word problems right now, and then we'll back off a little bit from them. I think I called that vaccinating. Yeah, vaccinating you against the virus of word problems, or it's mostly the fear of word problems. So what was another example that we talked about? We talked about sea level. Yeah, a scuba diver is 150 feet below the surface. That's called sea level, the surface of the ocean. It's not, I mean, it's just what we call sea level. It's not really level. It turns out that it's a big ball, but when you go to the beach and you look out at the ocean, it looks sort of flat, and we call that sea level. If he swims, or she swims upward 62 feet, what is the diver's current depth? All right, now this is a case where using the vertical might make a little bit more sense. Yeah. Although you still are allowed to do it horizontally, but we're talking about a scuba diver. So the scuba diver is down here at negative 150 feet. Okay, and they're going to swim up 62 feet. Now, you might be pretty good at mental math. Yeah. If you're really good at mental math, you already know the answer. The answer is negative 88 feet. That's your answer. And of course, I'm assuming that you're already relatively good at mental math. You're at negative 150 when you start. Now, by the way, the diver didn't get to negative 150 without actually swimming down there. But so I'm just starting this problem at 150, negative 150. Then he goes up 62 feet. You can use mental math. If he goes up 50 feet, right, they would be at 100, negative 100 if it went up 50. Yeah, so 12 more gives you 88. Yeah. Or if you're thinking of it as the other way around, it would be 12 less. All right. If you're not good at mental math, then you want to actually write it. You want to do 150 minus 62. And since you're still underwater, the answer is negative. Yeah. But you ignore the negative while you're doing the problem. So it's 150 minus 62. And then you say, okay, well, let's borrow from that. So 10 minus 2 is 8. And then 14, you can just consider that 14 minus 6 is another 8. Check. That's negative 88 feet. All right. So this is sort of the idea behind how negative numbers work in real life, or at least in an artificial example here. I mean, it could be real. It certainly could happen. It's not that artificial, but I mean, I did make this example up. I actually like the bank problems better because I think something that we can all relate to a little bit more than scuba diving. Not many of us have had the chance to go scuba diving, although if you have had the chance, it's quite an adventure under the sea. But something that we all have to deal with is money, all right? So let's do another problem with money. Suppose you have an overdrawn bank account negative $72. Right. Then you write a $43 check, and the bank charges you an additional $35 fee. What is your balance now? So again, let's go back to the number line. Here, I'm going to put 0 way over here to the right because all of these are going to be negative numbers. We're starting off at negative 72. Yeah, negative 72 in the red. Yeah. A check, that's also negative. So I'm going to go left. Yeah, go left. We used to call this subtracting. We now call it adding a negative. Used to be called subtracting. I am going to give a lesson on subtracting after I'm done with this lesson, but today I'm talking about adding. So when I'm going to the left, I'm going to go 43 units or $43 to the left of 72. So where am I at now? All right, if you're good with mental math, 72 plus 43 is 115. Yeah. So now you're at a negative 115 after going 43 units left of negative 72. And then you have a $35 fee. A fee is also negative. So go left again. So you're going to go 35 more units left from negative 115. Again, we're adding negatives. So when you add negatives, you're going to ignore the signs, add 35, and then just make the result negative. So the answer is you are now negative $150. Or we often say $sign and then negative 150. It turns out it really doesn't matter where you put the negative sign, but this is the way it will look on your assignments. It'll be the $sign and then the negative 150. You probably, this happens to you. I mean, this happens to everybody, right? Everybody gets overdrawn at some point, and you just kind of sit there in your head and you just keep going down, 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 or in this case, left, 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 until you get to your final result. But notice that you're adding all of these negatives. All right. So wouldn't it be nice to come up with a rule for addition? So using the number line takes a lot of time. So we only do it, so I recommend doing this only if you need more clarification. In other words, if drawing the number helps you to see it better, or if you are making mistakes. So if you're doing a problem and you're not drawing the number line and you're making a mistake, then I recommend drawing the number line. Yeah, the number line is sort of a safety net to avoid you from making mistakes. Okay. But if you don't need more clarification, in other words, if the line is not going to make the problem more clear to you, and if you're not making any sort of mathematical mistakes all the time, so the number line's not really there as a safety net, then otherwise we can use a rule to perform addition without counting on the number line. Because that's essentially what we're doing. We are counting on the line. We're going like this, Positive, add a positive. You move to the right, yeah? If you add a negative, you move to the left of wherever you're starting at. Okay, and you don't want to have to go 1, 2, 3, 4, 5, 6, 7, or -1, -2, -3, -4. You don't want to have to do that every single time. We want to have a nice rule for addition. So here is the rule, or here are the rules. One, same signs. In other words, both numbers are positive or both numbers are negative. All right, so something like this, 12 plus 9. All right, so in this case, both numbers are positive. If both numbers are positive, just add, as usual. Simple as that, yeah? If both numbers are negative, what you want to do is take the absolute value of each number, So the absolute value of negative 12 is 12. The absolute value of negative 9 is 9. add them. All right, so 12 plus 9 is 21. And then replace the negative sign. Okay. If you like a quick way to memorize this, taking the absolute value of each number is sometimes called ignoring. We call that ignoring the sign. Yeah, so negative 12 just becomes 12. Negative 9 just becomes 9. So we often say ignore the sign, but that really means take the absolute value. Okay, ignore, add, replace. So that's the same sign rule. Ignore, add, replace. That's the same sign rule. This is how the bank does it, yeah? If you owe the bank $12 and then you write a check for $9, the bank just adds the 12 and the 9 and says it's 21 and then puts the big negative sign in front of your answer saying that you owe the bank $21. That's the same sign rule. Different sign rule. So that means one is positive, the other is negative. It doesn't matter which one. So something like this. Negative 5 plus 8. So one of the numbers is positive, the other number is negative. Okay. So here's the rule for this. Take the absolute value of each. So you have the absolute value of negative 5, the absolute value of 8. That's 5 and 8. Absolute value of negative 5 is 5. The absolute value of 8 is 8. Subtract the smaller from the larger. So the smaller one is 5. And make sure you take that away from the larger. So the larger one has to go 8 minus 5. So you get equals 3. All right. And then finally, the last step, give your answer the sign of the larger. All right. Now that can be a little bit misleading because when I say the sign of the larger, I mean whichever one had a larger absolute value. I don't really mean which one was larger. So which one of these had a larger absolute value? The 8 had a larger absolute value. So the answer is positive. Same sign. So this is sometimes memorized as take the absolute value, subtract, yeah, and then give. And sometimes instead of take, what we'll say is ignore. So ignoring the signs, sometimes we call that taking. taking the absolute value of the numbers. All right, so those are the rules. I like to do a little quick reference up here. SSR, that's called the same sign rule. We take the absolute value, or in other words, ignore signs. We add and we replace. That's the same sign rule. The opposite sign rule, or the different sign rule, I'll say DSR, different sign rule. Some people call it the OSR, opposite sign rule. You take, you subtract, and you give. And again, when I say take, I really just mean ignore. All right, let's go ahead and do some problems. 1, 2, 3. Is this 4? Is this 5? I'll call it 4. Although it might be 5. You guys know me by now, right? It's just the next example. All right, let's go ahead and do it. Negative 13 plus negative 24. You can do all of this with mental math. All right, so I'm hoping that you're just doing all of this in the little cloud of your mind. Your little brain cloud up there. You can imagine it. Yeah. You still see a cloud when you close your eyes? You see a cloud of knowledge up there? So same sign rule. These are both negative. So we're going to take the absolute value. You can just do this mentally. That becomes 13. That becomes 24. You're going to add them together. 13 and 24 is 37. And then you're going to replace whatever the original signs were. So that's a negative. So negative 37. All right. So what do we got now? We got negative 25 plus 12. That's the DSR, or the OSR, the opposite sign rule. So again, take, subtract, and give. All right, so take the absolute value of these guys. That one becomes 25. That one becomes 12. Right, if it's positive, it just stays the same. Now subtract. 25 minus 12. 25 minus 12 is 13. And then give. Whichever one of these has a larger absolute value, 25 has a larger absolute value. Yeah, the absolute value of negative 25 is 25. So you're going to give your answer the sign of whichever one was larger. I hope that as you're doing this homework, not only are you doing the math and getting the right answer, but that you are doing it mentally as often as you possibly can, so that at some point it just becomes second nature. All right? You know, because I know what's going to happen, and that's that you can learn this, and then when you're going to get to the more advanced mathematics, if you have to stop and think about this every 2 seconds, it really starts affecting your success in the future. So the sooner that this becomes natural to you, the easier life is going to be as we move along. Let me erase the rules and see if we can do one just from memory. I'm just going to say add. Obviously, everything is an integer now. Okay, so here we go. We got it in our mind, right? We got the same sign rule. We got the opposite sign rule. All right, so our different sign rule. So this is different sign rule. So ignore the signs, subtract. You get 6. Whichever one's larger, the 14 has a larger absolute value, so your answer is just 6. Different sign rule. Excuse me, this was the different sign rule. Part A, different sign rule. Part B, same sign rule. These are both negative. So ignore the signs, or take the absolute value, add them together, and then give your answer the negative sign back. This is sort of the bank math, right? You were overdrawn by 22, then you wrote a check for 6, and so now you're overdrawn by 28. Yeah. And they haven't charged you the fee yet. If they charge you the fee, you're going to go even more overdrawn. All right. This is opposite sign rule or different sign rule. Yeah. So again, ignore the signs, subtract. You're going to get 4. Yeah, 9 minus 5 is 4. And then give your answer the sign of whichever one has a larger absolute value. If you ever get confused, just think about money. Yeah? If you owed $9, or if you're overdrawn $9, and then you made a deposit of $5, you would still be overdrawn by $4. Okay. The rules always apply 2 at a time, so you do 2 things at a time. You might have some problems that have more than 2 terms. Just use the order of operations to simplify these. So brackets are just another form of a parenthesis, although I need another one here. Okay. So you can just use all parentheses if that makes it a little bit easier. You certainly can. So you want to do these 2 at a time. 2 at a time. Start with the innermost parentheses. So whatever is the innermost parentheses, go as deep as you possibly can. All right. And work your way backwards. This will be the very last thing you do. I'm just going to copy it all down. And then whatever I get here is going to go here. That's the innermost. So 5 plus -9 is -4. And that's how you want to be doing it to be successful. I mean, you could stop and think about it and do all the rules and such. Practice the rules, but then you need to release yourself and go free. You know. Okay, next we're going to do this. -3 plus -4. They're both negatives, so -7. All right. And brackets mean the same thing as parentheses. So this means the same thing as 4 plus -7. You wouldn't want to write it this way because it would look funny and the computer would not really understand that, although you're not, all of this is going to be your scratch work anyway. I'm running out of room, so I'm going to move over to the right, although I try not to. I try to work only vertically until I get to the bottom of my page. -4 plus -7 is -11. And that's your answer. Let's do another one of these. Okay. So again, go to the innermost, start here. Start here. There's nothing to do inside of these parentheses. There's no more math inside of here, so it's just negative 3 plus 9. So that becomes 6. At this point, you can just go left to right. So this really just means 15 plus 6. So that's 21. Notice how I'm just sort of working down. I'm trying to keep a nice line. Doesn't have to be perfect, but it should be as close as I can get. So 15 plus 6 is 21. The brackets go away. Yeah, you're just adding them. So 21 plus negative 12. Yeah, you're going to subtract them. 21 minus 12 is 9. And then whichever one of these has a larger absolute value, 21 has a larger absolute value. So your answer is positive 9. You know, I started this with some word problems, or problems that involve words. The real word problems are still quite a ways away. The real word problems are problems that say, like, 5 more than 6 times a number is 4 less than negative 6 times another number. What are the two numbers? Kind of like mental puzzle problems that are actually sort of challenging your brain. I'm going to start feeding you those examples little by little. Let's start with some translating. You've probably noticed a pattern, right, in the way that I demonstrate things by now, right? I always start off with the philosophy. I give you the definition, the vocabulary. I show you the rules. Then we do some examples. Then we start translating, and eventually we'll be solving the real problems. So I go after it much the same way in every section. So translate into a mathematical expression. Then evaluate the result. What did I do? Well, we'll give it a second to think while I write down the... Come on back to me. I'll give it a second. We're so close to the end. I hate to stop the video now. That would be terrible. Make sure it's not my glasses. No, it's not my glasses. It's definitely blurry. Come on. Come to Papa. There we go. Translate to a mathematical expression, then evaluate the results. All right, so the expression, the sum, negative 19 plus 9. Yeah? Or, if you prefer, you could say 9 plus negative 19. If you write it this way, you need to use parentheses. If you write it this way, you do not need parentheses. I don't care. You have a choice. It's your choice. All right, either one. And then calculate the result. Negative 19 plus 9 is negative 10. That's the result. There's an L in result. There we go. Let's do a few of these. So anytime you have the sum or more than, or in addition to, anything that implies addition, you always have a choice of the two ways to write your answer. Okay. However, if I say the difference, so I'm not going to say the difference. I take that back. The difference would be subtraction. Subtraction is covered in the next lecture. All right. So if you say, say 5 more than -8, your expression has two choices. You could say 5 plus -8, or if you could prefer, you can say -8 plus 5. Your choice. In my next lecture, 3.3, coming very soon, we'll talk about subtraction. Subtraction is the difference, and you don't have this nice choice when we're talking about subtraction. But today we're talking about addition. And then so the result, -8 plus 5, or 5 plus -8, either one, it's your choice. The result is still -3. So I don't want to get too far ahead of myself. I start wanting to talk about subtraction, but subtraction's coming in the next lecture. The last thing, evaluating variable expressions. Evaluate -11 plus n for n equals 18. This is really no harder than what we've been doing. I'm just trying to mostly incorporate the vocabulary, and then using the rules that we just learned. Evaluate, if there's a variable, just means plug in. I will never say plug in on the test or the quiz or the homework. I'll always say evaluate, because I want you to learn the value. It turns out that if I tell you, plug in, which I am now, but you really will just expect me to say that all the time. So I'm not going to do that. Now, technically, I should probably use parentheses. Yeah, to be safe. But once you realize that you don't need them, you may omit if the variable value is positive. We typically don't put parentheses around positive numbers. It's not necessary. However, if this was a negative number, I would definitely keep the parentheses. So I have -11 plus 18, so that would be 7. Yeah. And again, I just think about money. If I owed $11, so I was overdrawn $11, and then I made a deposit of $18, assuming that there's no extra fees, I would now have $7. All right. Sometimes we have more than one variable. I think my pen is going to be retired after this lesson. Evaluate, I'm just going to switch now. X plus y, when x is -15 and y is -12. So remove the variables, replace them with parentheses, You could always erase the parentheses if you find out you don't need them. And then plug in these values, -15, -12. We're adding two negatives, so that's the same sign rule. That's -27. That's the result. All right, just in time because this pen is now dead. I'm going to have to go get a new pen before I film the next video. I'll see you next time for subtracting integers. Until then, this is Dr. Jordan reminding you, do your homework. See you on the internet.